Okay, in this Ed Puzzle, we're doing the last couple of problems from that review that we started today. And then your test is on Thursday or Friday, depending on if you have me A day or B day. All right, the TSA is responsible for airport safety. On some flights, TSA officers randomly select passengers for extra security before boarding. One flight has 76 passengers, 12 in first class and 64 in coach. The TSA officers selected a simple random sample of 10 passengers for screening. Let P hat be the proportion of first class passengers in the sample. Is the 10% condition met? Justify your answer. All right, first, tell me, what is the 10% condition for? All right. Next, what's the 10% condition formula? All right. Let me go ahead and... So the sample size has to be less than 10% of the population. All right, so what's my sample size here? Sample size, simple random sample of 10. So my sample is 10. And now my population is everybody that could have been selected in the sample. So it looks like my population is 76. All right, so 10% of 76 is actually going to be 7.6. So is the 10% condition met in this scenario? No, it is not. So we cannot proceed. We cannot use the standard deviation formula, so we cannot use this to calculate any probabilities. All right, large counts condition. All right, what is the large counts condition for? All right, and then what is the large counts condition formula? All right, my successes and my failures must be greater than or equal to 10. So remember, successes is n times p, and failures is n times 1 minus p. All right, so we know our n is 10. All right, what's our probability of success? All right, I hope you got 0.1579. How did I get that? Well, first I got to figure out what a success is. Looks like it says let P hat be the proportion of first class passengers. So out of the 76 passengers, how many are in first class? Looks like 12. And then my failure probability will be my coach, which would be 64 over 76. So go ahead and calculate my probability of failure. If you got 0.8421. Now, all of this calculating means nothing, right? Because I'm going to fail it in both scenarios. My sample size is 10. So if I'm going to multiply 10 by any sort of decimal, that means it's going to be less than 10. So I fail on both accounts, successes and failures. So since my successes and my failures are both less than 10, I cannot say that I have an approximately normal distribution. All right, number 6. Suppose that 70% of college women have been on a diet for the past 12 months. A sample survey interviews 267 college women. What is the probability that 75% or more of women in the sample have been on a diet? All right, so we're looking for probability, right? So I should probably do my 3 checks. Number 1, do I have a random sample? Yes, I do. So I'm good there. I can generalize back to the population. Number 2, is the 10% condition met? Is 267 less than 10% of all college women? I'll just abbreviate that as all college women. yes, I would say that it's safe to say that 267, there's more than 2,670 college women in the world, right? Okay, so we met that. We can use the standard deviation formula. Large counts. So we want to make sure our successes and our failures are greater than or equal to 10. So that's going to be 267. Now here's the problem. Am I going to use 0.7 or 0.75? 0.7. I always use n times p, the true population. So that's my successes, and this is my failures. All right, let's see what they are. Make sure they're greater than or equal to 10. Yep, I get 186, or technically 187 if I round. And then 80. Both of these are greater than or equal to 10, so I am good to go with the normal distribution. So I can calculate my mean and my standard deviation. Let me go ahead and draw out my normal distribution. Alright, so what's my mean? What's my mu of p hat? Alright, if you look at your formula, I hope you're saying your mu of p hat is equal to p. P in this scenario is 70, not 75. 75 is a p hat because it comes from the sample. So my mean is 0.70. Alright, now my standard deviation, which is going to be my sigma of p hat, is equal to the square root of p times 1 minus p over n. Alright, so let me go ahead and plug that in, and I'll estimate it. So my Desmos app, I'm doing square root of fraction 0.7 times 0.3, and I'm going to have 267 in the denominator, and I get 0.028. Alright, should I draw my value to the right or to the left of the mean? Alright, I hope you realize the value is the p hat, 75, so that's above 0.7. Alright, now should I shade to the left or the right? So that's what is the probability that 75% or more women in the sample. So I'm going to shade to the right. So this is the area I am trying to find. Alright, let me go to Desmos. I'm going to do functions, distribution, normal. My mean is 0.7. My standard deviation is 0.028. Alright. I end up writing that 0.028. Alright. And then is my min going to be 0.75 or my max? My min, because I'm shading to the right. So there is my probability, 0.037. So P is equal to 0.037. Or 3.7%. Alright. Last problem. Every day people watch 1 billion hours of YouTube. This breaks down to a single person watching 8.4 minutes a day. In the US, any given day, the amount spent watching YouTube is approximately normal with a mean of 18.5 and standard deviation of 5.3. All right, so are we in the world of means or the world of proportions? All right, I hope you said the world of means. So it says, find the probability that a randomly chosen U.S. teen watches YouTube for more than 25 minutes in a given day. All right. We don't really have a sample here, right? We're just randomly choosing one. So we're not talking about sampling distributions. We're just talking about a sample of one. So all I'm going to do is take my mean and my standard deviation and find the probability. So I know that the population is approximately normal because it tells me in the problem. I know that my mean is 18.5 and my standard deviation is 5.3. Now remember, I'm not using those formulas, the sampling distribution formulas, because I'm just randomly selecting one. I'm not doing a whole bunch of samples for a sampling distribution. All right, we want to know more than 25 hours. So if my mean is 18.5, I'm going to draw my 25 hours to the right, and I'm going to shade to the right because it's more than. All right. So let me go here. I'm going to change it to 18.5. And 5.3, I think. Let me check. Yep. And then my min is going to be 25. There we go. My probability is 0.11, 11% likely. All right, now suppose we have a simple random sample of 10 U.S. teens. So now we actually have a sample, so we would have an X bar, the mean amount of time of watching YouTube videos from this sample. What is the mean of the sampling distribution of X bar? So the sampling distribution is a whole bunch of different samples, right? So let's go back to our formula sheet and figure out what the mean, the mu of X bar is. So go ahead and let me know what that would be. All right, the mu of X bar is just the mu of the population, which above they told me was 8.4. So the mean of the sampling distribution is just 8.4 minutes. All right, C says calculate and interpret the standard deviation of the sampling distribution, verify the 10% condition is met. I need to do the 10% condition before I use the standard deviation formula. All right, so my sample is 10. Is 10 less than 10% of U.S. teens? Most definitely. There are definitely more than 100 U.S. teens in the world. All right, so my 10% condition is met. Now let's go ahead and do the standard deviation formula, which is the sigma of X bar. And that's going to be the standard deviation over the square root of n. My standard deviation, if I look back up here, is 5.3. So 5.3 over square root of the sample size, which would be 10. We have a simple random sample of 10. All right, let's plug this into Desmos. And I get 1.676. Does this have any units? Yes. Remember, proportions don't have units, but means do, because we're talking about quantitative data. All right, nice job. Good luck studying, and I'll see you all for the test on Thursday or Friday.